Okay, so in the last lesson we have talked about some aspects of triangles, which were pretty much class 7th, 8th stuff. And I also showed you a high-end problem where you realized what I wanted to show you was that that even at the high-end problems, if your basic visualizations are good, you can pretty much handle any questions in geometry. And the best part of geometry in the context of competitive exams and also in the context of board exams, etc., is that it's just maybe three steps or 4 steps maximum that you need to execute. But the visualization agar hai, if you got the visualization, you'll be able to see those steps, otherwise you'll not. So let's complete our basic visualization of geometrical logics, and this includes the next part. Now we have done extensively in the first class. We have done exterior angles and interior angles extensively. Today I want to first focus on perpendicular bisects, the three lines that are there on every triangle: the medians, the altitudes, and the perpendicular bisectors of the sides. An altitude of a triangle is important because the area of a triangle is given by half base into height. So that is one of the reasons why the altitude of a triangle is important, because the height is basically measured through the altitude. So you need to understand these three terms pretty well. So let's first focus on our on the first of these parts, the perpendicular bisector of sides. Right? So suppose I have a triangle like this, where all the sides are equal and all the angles are equal. So in this triangle, what happens is that the perpendicular bisector, as the name suggests, is essentially created by identifying the midpoint of a side. So if you identify this as the midpoint of the side, let's say this is the triangle ABC, and I call this M1. And if you draw the vertical or the perpendicular to that side from that midpoint, and you extend that perpendicular on both sides, so this is referred to as the perpendicular bisector of this side, of the side BC. Now, what you should be able to understand is that there will be three perpendicular bisectors because there are three sides and three vertices. So there will be a perpendicular bisector that can be drawn from here also, and that perpendicular bisector will look like this. Please remember, I have taken an example of an equilateral triangle here. I have taken the example of an equilateral triangle here. And in an equilateral triangle, you will notice that the perpendicular bisector of the side also passes through the other vertices. But this need not always be true. And likewise, the third perpendicular bisector comes from here. And you'll also notice that whenever you draw the perpendicular bisectors of the sides of any triangle, not just equilateral, they'll always intersect at a single point. They'll always pass through a single point. That's a property that all triangles will have. But more on that later. Abhi ke liye, let's first understand this. So in this equilateral triangle, you can see that the perpendicular bisectors of every side is passing through the opposite vertex. So the perpendicular bisector, let's call this P1, P2, and P3. And you can see that three perpendicular bisectors. P1 passes through A. P1 is the perpendicular bisector of the side BC. P2 is the perpendicular bisector of the side AC. And P3 is the perpendicular bisector of the side AB. And you can see that pretty much they pass through each other. But if you have, let's say, a normal triangle, which is not equilateral, let's say we talk about a scalene triangle, like this, or let me make it even slightly more dramatic in terms of its drawing. So in this case, you can notice that if I want to bisect my base, let's say my triangle is ABC. So if I define my base as BC and I want to bisect it, the midpoint of BC might be somewhere here. In this case, the perpendicular bisector will not pass through A. It will bypass A when you draw it. It will not go through A. And likewise, if you want to draw the perpendicular bisector of this side AB, then it will not necessarily pass through C. If you draw the perpendicular to that, not being able to draw that very well, let me just take the line tool here. So if I draw the perpendicular bisector of this, it might pass. It might not just might, it actually will most of the time not pass through. So C, it will bypass C. And likewise, the perpendicular bisector of AC. This part will always be true, that they will all intersect at the same point. So when you're drawing the perpendicular bisectors, they will have to pass through the same point. It can't be that P1, P2 intersect at some other point and P2, P3 intersect at some other point. So in this case, if this is P1 and this is the second perpendicular bisector and this is the third perpendicular bisector that I have of the sides, they would be intersecting at some point. Right? We'll talk about the definition of these points, etc. Later. But first, let's understand these three lines, and then the fourth one also, which is the angle bisectors. तो ये perpendicular bisectors हो गए, perpendicular bisector visualization हो गया. I would encourage you to also think of the perpendicular bisector if my original triangle is obtuse. If my original triangle is obtuse, or let me draw this again with the line pen. If my original triangle is obtuse, how do the perpendicular bisectors stack up? So in this situation, you can see that your perpendicular bisectors of this side will be a perpendicular drawn to this. Let's call this the triangle ABC. So on the side AC, the perpendicular bisector will pass through the midpoint and go straight up that way, right? And the perpendicular bisector of this might pass like that. And the perpendicular bisector of the third side, if I draw with of course there's a little bit of play in my drawing here, but you can see that the meeting point of the three perpendicular bisectors need not always be inside your triangle. In this case, if this is M1, the midpoint of the first side BC, and this is M2, the midpoint of the second side AB, and this is M3, the midpoint of the third side AC, then in that case, when I draw the perpendicular bisectors from the midpoints of the respective sides, you can see that the meeting point of the midpoint of the perpendicular bisectors is lying outside the triangle, not inside. Right? So this is something you need to consider in this situation. That this might happen a lot of times, and specifically for obtuse angle triangles, this would happen, right? Then we come to the other next important line that is there in triangle. Then please remember there are three different perpendicular bisectors that you can draw for every triangle. So let's look at the second one, the medians of a triangle. So जब तुम medians को देखते हो, when you look at the medians of a triangle, the median basically means that you are connecting the midpoint to the opposite vertex. So if I talk about the general logic for a median, the general logic for a median is that if this is my midpoint of the side BC, if this is the midpoint of the side BC, then the median is this line which connects the midpoint of the side BC to the side to the vertex A. And just like there were three instances of the perpendicular bisectors, there are three instances of the median also on every triangle. So if I connect this point, which is, let's say, M2 to C, this is my second median. Let's call it the point M2, midpoint of AB. This is my second median. And likewise, if this is my third median, then it will, the way it would get drawn, I got to play here on my picture, but essentially this will have to pass through the same point, right? They will all pass through the same point. So this is my midpoint M3 on AC, right? And these are my three medians of the triangle. Okay, we'll look at the formulas and theorems around medians later in a higher session, in a higher class. But this is what M1, M2, M3, the three medians of a triangle look like. And I would encourage you also to think about the medians. Try to think about medians for equilateral triangles. Try to think of medians for isosceles triangles. Try to think of medians for scalene triangles. These are the three ways in which triangles got segregated based on length of sides and also based on angles. Try to think about medians for acute angle triangles. How do they look? Try to think about medians for right angle triangles. And try to think about medians for obtuse angle triangles. So maybe I'll pick up one or two of them and show you. Let's say we go to right angle triangles. How do the medians look like in a right angle triangle? So if I go with a conventional picture of a right angle triangle with the right angle on the left side, like that, my medians will look like this. This is M1, this is M2, and this would be how M3 will look like. This is the median passing through the midpoint of this side. This is the median passing through the midpoint of that side. And this is the median passing through the midpoint of the hypotenuse in a right angle triangle. This is how the three medians will look like. Right? Perpendicular bisectors, of course, will look for a right angle triangle. If I want to think about the perpendicular bisectors on the same lines, so on M1, if I draw the perpendicular, let's say this is the triangle ABC, and on the triangle ABC, if I take the midpoint of BC and draw the perpendicular from there, then this is the perpendicular bisector of BC. What we drew earlier, this was the median on BC to the vertex A. Right? And you can also start visualizing that in the case of an equilateral triangle, the perpendicular bisector and the median will be same. They would coincide on all three sides and all three vertices. So if we go for an equilateral triangle, you will see this happening. Let's try to draw a good quality equilateral triangle here. And this is my equilateral triangle. Then this would be my median as well as my perpendicular bisector of the side. And likewise, this would be my median and perpendicular bisector, and this will also be the median and perpendicular bisector of all three sides. So in this case, you can see that the median and the perpendicular bisector on all three sides are same. So this line that you see here is the median of this triangle on the base BC. It's also the perpendicular bisector on BC. And likewise on isosceles triangles, they have another interesting property, that for an isosceles triangle, the median and the perpendicular bisector for the base, which is the side which is different from the equal side. As we know, equilateral triangle, isosceles triangle is a triangle in which two sides are equal. So isme, if you look at the non-equal side, let's say BC is the non-equal side, the third side, then if you take the midpoint of BC, let's call it M1, and you draw the perpendicular bisector, it will pass through A again. So this will be true on this side, but it will not be true on the AC side, for example. So if I try to take the midpoint of AC for an equilateral triangle, for an isosceles triangle, so its perpendicular bisector might pass outside B. It will not necessarily pass through B, right? So this is something that you should realize, which as you start visualizing the formulas and the various kinds of lines, that becomes important to see. And the third one is the altitude of a triangle. So altitude basically is the height of a triangle. So whenever you have any triangle, let's say I go for a scalene triangle like this. So a triangle like this, if I take this as the base level and this is the top level, you can see that this triangle has its height from here to here, right? So this line here to this line here is the height. So you can actually think of the height of this going from the base to the opposite vertex. This is the height of the triangle. And to look at the height of the triangle, or the altitude of a triangle, more commonly referred to in geometry as altitude, please remember the median and the perpendicular bisector. While drawing them, we had identified the midpoint of the base and then connected and then drawn from here. This was my initial point for drawing. So when I went for perpendicular bisector, I drew a perpendicular to the base from here. When I wanted to draw a median, I started drawing from here and went to the opposite vertex. But when I'm trying to draw the altitude of a triangle, my starting point is the vertex, not the midpoint of the opposite side. And from the vertex, what I do is I have to drop a perpendicular to the opposite side. When I do that, the length of this segment that we have drawn, this line that we have drawn, the yellow line, that is the altitude of the triangle. And because there are three vertices to a triangle, there will be three different altitudes. So one altitude which you see here naturally is this altitude. And the second altitude can be visualized for the same triangle, can be visualized by drawing this line parallel to this. And again from here drawing a line parallel to this. And if you look at the perpendicular distance between these two, the straight line distance between these two lines, this will also be the height of this triangle. So please remember that this is the height of the triangle. This is the second height of the triangle. And you can also draw a third height to the triangle by extending this or thinking of a line like this. Let's take a different color to show this. If I think of this line which is going parallel to this side, let's name the sides, name the vertices A, B, C. So this is the height, H1 is the height on the vertex B to the side AC. H2 is the height on the vertex A to the side BC. And H3 will be the height between these two parallel lines, the distance between these two parallel lines. This would be S3 for this triangle. and S3 is the height on the vertex C and the base AB. This is the height S3. And why H1, H2, S3 is significant is because we know that the area of a triangle is half base into height. And what you need to understand is that because you have three different heights and three different bases, there are three ways to calculate the area of a triangle. This is a very commonly used structure in a lot of geometry questions. And just like I showed you a question on exterior angles, in this one I'll not do now because this is supposed to be a basic session. I can show you maybe 10, 15, 20 instances of questions in the actual exams, various levels, which use this property that the area of a triangle can be measured on different heights and bases. So half, your visualization should be complete at least at this point. Half AC into H1 will be equal to half BC into H2 will be equal to half AB into H3. And that is because for the height H1, the base is AC. For the height H2, we have taken the base as BC. And for the height H3, we have taken the base as AB. Right? As I said, this is a very, very important property in triangles. And you should realize this while using half base into height for the area of a triangle, that you have three options to use this, not just a single option. Right? There's one more terminology with respect to triangles, the lines inside a triangle, which I have not put here, but that is basically the angle bisector. Before I come to the angle bisector, one more thing. Again, you will see that for an equilateral triangle, the perpendicular bisectors, the medians and the altitudes, all three are same. So on an equilateral triangle, you will see that the perpendicular bisector, I mean, if you think of this as the triangle ABC, where AB and C are all equal to each other, AB, BC and AC are all equal to each other. And if I look at this point as M1, the midpoint of the side BC, then the line I've drawn here, the line which I'm now going to make white here, this line is all three. It is the perpendicular bisector of the side BC, it is the median of the triangle ABC with the base BC and the vertex A. It is also the altitude of the triangle drawn from the vertex A to the side BC. And this will be true on all three sides. The perpendicular bisector, this might not look very, very good because I've not drawn a very good equilateral triangle here. But if you draw it to measure, you will see that the perpendicular bisector, the medians and the altitudes of all the three sides will be equal to each other. And from here, when you go on to an isosceles triangle, you again see in an isosceles triangle, you'll again see in an isosceles triangle that on the vertex, which is on the top, on the vertex which is on top, from which the two equal sides flow. So in this case, AB and AC are equal. So if you were to draw the altitude from A to the side BC, or you are trying to draw the median from the point M1 to the vertex A, or from M1 you try to draw the perpendicular bisector of BC, you will see that these three coincide. This is the perpendicular bisector of side BC. It's also the altitude from vertex A. It is also the median between the midpoint of BC and A. So these three coincide, but they do not coincide on this side or on this side. So that means when you draw the perpendicular bisector of AB, it will go somewhere. It will not necessarily hit C. Not just not necessarily, it will actually not hit C, right? But on the equal on the non-equal side on an isosceles triangle, if you draw the perpendicular bisector or the median or the altitude, you will see that they're all equal in this case, right? And as I said, the fourth terminology with respect to lines inside a triangle, the fourth terminology is the angle bisector. So this is not very commonly used in advanced problem solving, but you should know what an angle bisector is. An angle bisector is basically the line that bisects the angle. So if this is, let's say, if this angle is 70 degrees, so the line which will split this angle into 35 is the angle bisector. And again, on a triangle, there will be an angle bisector to each of the three angles. So this is the angle bisector. Interesting thing again to note that the angle bisector, all three angle bisectors for an equilateral triangle will coincide or will be just a replication of the altitudes or the medians or the perpendicular bisector. So these four will all be equal for an equilateral triangle. On an isosceles triangle, these four will be equal when you are talking about the vertex, which is the common vertex to the two equal sides. Perpendicular bisector, the angle bisector, the median as well as the altitude will all be same on this vertex, not on the other two vertices. वहाँ पे vertices वहाँ पे अलग रहेगा. तो ये हो गया तुम्हारा basic terminologies of triangles which you should know. ठीक है? There'll be, of course, we'll look at other things. There are points or there are measurement angles, logics with respect to medians of a triangle, also with respect to what the perpendicular bisectors and the altitudes meeting points are called, etc. We'll come to that a little bit later, right? Next lesson, I'll be talking about the congruence of two triangles. There are four stories of congruence: SSS, SAS, ASA, and RHS. So we'll also explore why do we not have something like an SSA congruence of triangles. What does congruence mean? Because that's something again which you need to understand clearly to be able to be equipped with your geometry problem solving situations. So I hope you're enjoying this this course, and I'll come back to you with the next lesson very soon. Chalo, bye bye.